Our next speaker is Vernon Hall. He is the Earthport Harbor Master for the International Space Elevator Consortium and president of Galactic Harbor Associates. Mr. Hall is a professional engineer with a long career in the transportation industry, working on freeways, rail yards, ports, bridges, pipelines, and now space. He spent 27 years at the Port of Los Angeles, where he played a leading role in redeveloping and expanding it from a regional port into the largest container port and intermodal complex in the Western Hemisphere. Mr. Hall earned his engineering degree from UCLA and is active in a number of professional organizations. Go ahead, Mr. Hall.
Well, first of all, I'm honored to being the last presentation of this session is quite an honor to me because, as Lee said, I am a civil engineer, not an aerospace or a scientist of some kind, and the title, which I did not choose, is quite pretentious. But it is appropriate. So let's move on to the next place. I actually got involved in intermodalism when I started with the Port of LA as a not so young civil engineer. It was a point where the entire port industry was transitioning from what's known in our industry as break bulk cargo. I think the best image, which I don't have for you, I'm sure you've all seen the film On the Waterfront. Well, Marlon Brando and his gang and Johnny Friendly are all gone. But at that point in time, it was still the way most cargo was handled. Ships came in, berthed alongside, and they were offloaded onto a dock or to a wharf using their own equipment. They were put on pallets. And in order to protect the cargo, they moved directly into a warehouse, or what was called a transit shed. All of that changed with the concept of containerization, which I'll show you in a minute. Next slide, please. You've seen this before. It's a piece of the image of the Galactic Harbor, the unifying vision. And of course, the focus today will be not on the Enterprise, but on the Galactic Harbor as a permanent transportation infrastructure. Next slide, please. Today, like most infrastructure, people take infrastructure for granted, as many of you may know if you're in that business. They only notice infrastructure when it fails to work. A great example a couple of weeks ago occurred in Texas. The power went out. The windmills froze. And all of a sudden, who's going to fix it? What happened? Is it the politicians' fault? Is it the utilities company's fault? Like I say, it's only noticed when it doesn't work. Same thing applies to transportation. I had a personal example of that myself. I ordered a microwave for Christmas on Black Friday. Going to be delivered by Amazon 10 days later. Halfway through January, I finally got it. Now, what happened? Well, it came from somewhere in the Far East, maybe China, maybe Vietnam, put on a container ship and delivered to the Port of Los Angeles. Unfortunately, thanks to COVID, the Port of Los Angeles wasn't shut down, but it was slowed down by labor. So labor is a link in that transportation chain. Anyway, there are many components in the transportation system. The obvious ones are ships, which have grown dramatically in size. Trucks is a basic, traveling our interstate highways. Trains, which have grown from local service trains to unit trains. Our nation and the entire world is underlain with pipelines moving liquid cargo around, and of course, aircraft. And there are hundreds of businesses involved in the transportation chain. Shipping and trucking lines are obvious, seaport and airport terminal operators, custom agents, officials, labor unions, and they're all interconnected in what's now known as the global logistics supply chain. Next slide, please. It's a bit of a complicated mess, as you can see in that little thing, image I pulled from the internet. Many players involved, but it's come together, and they're using ever increasing bits of technology. Blockchain technology, which I don't profess to understand, even though I've tried to, is now being used as a standard way of transacting business in the cargo movement business. They're using the Internet of Things. They're using artificial technology, remote sensing, analyzing metadata. They're even moving into autonomous ships, autonomous service craft now, to tugboats and ferries in Europe particularly. And of course, one more, hold it. Okay, next slide, please. Forget the of course. Anyway, this is another image of the intermodal system, the massive container ship, the trucks that roam the highways, the unit trains, and the airplanes. But it's a two-dimensional system. It hugs the earth. It crosses the earth, it crosses each of our countries, but it, of course, doesn't go into space. Now, today's going into space by rocketry uses this system. The components are built somewhere, they're transferred by truck into Cape Canaveral or Vandenberg, but it's not an integrated system yet of getting into space. I think you also, but it's become the global logistic chain has become a profession now. In fact, you can get degrees in global chain management from such prestigious universities as USC, the Marshall School of Business. Excuse the phone call. But what one thing, and I think we know the answer, Kevin, is what one thing made all this happen, and that, of course, was, next picture, please, the container. This is the key component that created intermodalism, and that was the standardization worldwide of a shipping container. Let me refer to my notes here for a moment. This was actually a one-man's idea. His name was Malcolm McLean or McLean, a Scotsman who was a trucker working in and around the port of New York and New Jersey. He saw the inefficiencies of handling, double handling, triple handling cargo in break bulk. He saw the inefficiencies of moving cargo from ship to warehouse to train or truck. And you needed the warehouse because you had to protect the cargo no matter what it was. And so he came up with the concept of a standardized container that could be used by a truck, by a ship, and by a train. It started out much smaller than this, but a couple of dimensions are pretty much have not changed. That's the 8-foot width, the 8-foot 6-inch height, and the original containers were 20 foot in length. In fact, the term 20-foot equivalent unit is now standard throughout the world. He also, and this is very, I think, appropriate to what we'll talk about later, is how we start building the space elevator system. He also used and adapted existing equipment. They were shipping containers before use, and so he started developing standardized truck widths, standardized trucks lengths. If you've seen the so-called big rig on the highway, it's basically a road tractor and a chassis. And the chassis is designed to hold the container safely and securely aboard. And then, of course, it's disconnected when it gets to its destination. So they standardized the chassis, they standardized the power requirements for the rigs. And as the industry evolved, the shape of the terminals at the ports and the shape of the terminals at the trucking centers changed. They needed more and more land. They started developing specialized equipment, such as yard hostlers, they call, that move the containers on chassis around the yards. I should have got some water here, I'm sorry. In the rail, using that same container, he first put the chassis on wheels with the container on it on a flatbed rail car. That was called container on flat car. When I first started designing facilities for that, that's what we were dealing with. Then he figured out a lashing method so the chassis didn't have to go with it. So it became container on flat car. And then the design of the flat car was changed to allow a lower bed so you could stack two containers on top of each other. And then the height of them became of course, a key dimension as you cross the country, passing under bridges and going through tunnels. So this just continued to evolve. And I think that's exactly what's going to happen as we start developing the equipment, much more sophisticated, of course, for the space elevator. There's a very excellent paper out written by Kevin Berry, and I'm going to quote him for it, and quote from it. And it says, the standardized shipping container accelerated trade, increased economic productivity, and made shipping a safer and more reliable sector. Brilliant words and absolutely true from my own experience. Next slide, please. So the beauty of it is you can manufacture your product, say, in China, shall we say, put it in a container, seal the container, lock it tight. The knowledge of what's in that container, along with everything else in it, will be recorded digitally, and it'll be taken to a marine terminal where it's loaded upon a container ship, along with literally thousands of others. Takes about 2 weeks to get from China to, say, the port of LA or the port of Long Beach. Lifted off, set briefly at a container terminal, and then transferred to either a truck chassis to go to a regional warehouse for regional distribution, or in many times put on a unit train, which is about a mile long, that will take it across country via initially the Alameda corridor, which I'll talk about in a minute, and then literally can go either to a distribution center in Chicago or all the way to the East Coast and possibly put on another ship. This was called land bridge. It was made possible by the fact there is an intercontinental railroad. So I hope you can see the parallels of what's going to happen as the space elevator railway or main channel, global galactic harbor main channel develops over the years. By the way, this was, again, I think Kevin said it clearly, that this was the transportation story of the 20th century, or one of them, the concept of intermodalism. And I was around to see part of it and actually contribute to it. I'm not quite old enough to be part of the opening of the Panama Canal or the actual building of the Transcontinental Railroad, but I hope to be around maybe to see the beginnings of the 21st, our transportation story of the 21st century. But anyway, the key thing is that the galactic harbor will tie an existing, ever more sophisticated system into that third dimension, taking things to and from space, and the nexus point for all that will be the Earth port. Next slide, please. I won't take you through all this, but this is one of the first things I did for Pete and Fitzer, was to come up with this little simple block diagram. We use the existing system of air, highway, and rail to get your product or your cargo or your payload to a Earthport access city, which is shown in the middle blue there. And at that point, it'll come under control of some operating company and enter that third dimension. From there, it'll be transported to I don't have the control of the pointer, I guess, but the blue box down from the top is the Earth port, and then from there it goes into space using the climbers via the terminal, the tether transfer facility. Excuse me, tether transfer platform. Let's take another slide, please. One of the aspects of the Earth port transportation system, or this galactic harbor transport system, is reliable, regular, safe, secure, on-time delivery. Now, it takes a long time to get there on time, but it doesn't matter. Pete used the example of hammers and nails. If you have high-value, small mass cargo that you really have to get there tomorrow, today, you put it on an airplane and get it there. However, for almost the history of mankind, if you want to move large masses of cargo or people long distances, you use it by ship and or by rail. Most of the great cities of the world, of course, are built on rivers or ocean fronts. That's because it's transportation of getting stuff there. And again, in the future or today, if you want to get things into space quickly or through the radiation belt, you're going to use rocketries. But again, the point's been made several times today. If we have large masses of payload and can be on a regular schedule, we're going to use the elevator. Next slide, please. So we've discussed they've been discussed before, and they're contained in one of the ISEC reports. Some of the key attributes of the galactic harbor are the access city. This is where the business will take place. This is where the contracts will be signed with the providers, with the cargo. It'll have and it'll be the point where it'll go on to the floating ops platform, the tether terminus platforms. I believe I'm working on something which will tend to standardize the space elevator containers, which will then allow us to standardize the climbers. The earlier ISEC report showed a number of different concepts, most of them cylindrical in shape, and most of the imagery is that. But I think there's a chance we might take advantage of the standardization that's occurring in today's conventional intermodalism and adapt that to the space elevator. But the key elements are safe, reliable, routine, cost-effective with minimal environmental impacts. The other thing that sets, I think, the space elevator transportation system apart from rocketry is and this is what civil engineering look at, so I apologize to the space scientists that might be in the audience, but our goal is to create a regular activity. We send something up every day, and the something is about today the size and shape of one of those road containers you see on trucks throughout the country. To me, rocket launches are still events versus activity, if you see the distinction. And some of the numbers thrown out earlier are just a little amazing about how many launch events are going to occur in order to achieve some of these missions. I think there's a reason for skepticism there, shall we say. Next slide, please. Okay, this is a civil engineer doing naval architecture. Not a good idea always. But this is the floating operations platform taken out of the water. Obviously, it doesn't float above the water, but it does show the underlying structure. We have conceived this as a semi-submersible offshore floating structure. And in these big pontoons are all the machine spaces, the engineering spaces, the ballast tanks. It can be self-propelled. It can also be hauled around by tugs and so forth. Waterline is about at the face of that large flat dock you see there. That's where the cargo handling will take place. receiving and then departing for the tether terminus platforms. I've also provided a little internal marina and the number of workshops that Fetzer mentioned earlier. The upper decks will be kind of like a cruise ship because they'll house a lot of people. And the top two decks in the gray there will be the home for the operations and control center, which will be, I think, due to the communications requirements and the directive requirements to operate the system, will be quite large and equal some of the ones we see on television and some of which you've probably all been to. And then the top deck, of course, will have helicopter pads and all of our communications, antennas, and so forth. I've even, you may notice, I don't know how big your picture is, but I've even thrown in a tennis court there and probably a golf putting green or two. Next slide, please. There's the control system we've seen before. Next slide, please. So I'm rambling a little bit. Again, I'm in awe of all the information that has been presented today. But the key here is that as we develop the Galactic Harbor's transportation infrastructure, it will indeed plug into and expand, that's the key word, the capabilities of today's global logistics supply chain. It will assure scheduled delivery of large masses of payload to GEO and beyond in a safe, reliable, and routine manner. And as several people have mentioned, it provides a complementary access to space, which is absolutely necessary to achieve the planned missions. So I'm sure I didn't cover everything I was supposed to, but I appreciate the opportunity and love to take any questions. Thank you. Or comments.
I see some discussion in the chat, but I think it may be left over from a prior talk. Any questions for Mr. Hall?
I have one quick question. Yeah. Vernon, there was a master's student that came from Finland or someplace like that and did his studies in Japan and then wrote a 400-page document on where we ought to put the space elevator. You want to comment on that? I think it's an excellent start at an analysis, and then you took it to the next level.
Well, I did. I wrote a little paper and presented a couple of years ago and I think it's online somewhere on our website. But the original studies conducted by ISEC about the port access city they kind of brushed it off. They had to be somewhere, near the equator. And I took it a little further based on just the realities of the existing system. And I believe that the access city should have a business climate that's acceptable to the international community, probably a monetary system that's accepted, an international airport because planes are scheduled and cargo planes arrive on schedule, and most importantly, a deep water harbor so that scheduled ships can arrive. This is so-called liner service. And then having a deep water harbor would also have a smaller harbor that could be used as a checkpoint for getting our cargo on smaller ships out to the port. Out to the mental block here. Out to the earth port. The earth port should be, as we know, somewhere near on the equator. And I kind of came up with maybe Honolulu would be a better location than somewhere in the Galapagos Islands. So that's, however, the young man in question came up with the same answer, and other people have studied it from different directions, including climate, wave conditions, and all that. And they pretty much come up with the same conclusion that maybe our first earth port should be somewhere south of Hawaii, which is about a day and a half trip by sea from Honolulu. It's only a few hours, maybe an hour and a half by high-speed plane. You can be there in a day by high-speed ferry. So it's a pretty nice place to do business, of course, and get our project started. With 8 locations, not 3 as you're proposing, but 8 locations around the world. It's quite an interesting story.
Why would you use an ocean-based platform when staying away from weather seems like a good idea? That question is from Martin Horowitz.
The main problem is there's not many good places around the equator where you could build one on land. And the equator, of course, is very benign. It's in the doldrums. And it's another, because that's why we conceived of the floating operations platform as floating. Certainly it could be built on land, or it could be built on an island. And I'm sure some of the locations that China is looking at will be exactly that. And I think if you look at the Obayashi plan, it's also shows the actual launch point reached by a causeway from existing land. I'm not quite sure where they're putting it, but so yeah. But the features that go into it can be built on a floating platform. We've tested my little concept against some reputable, world-known, well-known naval architect. They say, sure, we can build this. And by the way, it could be built today with funding. It's going to cost about $600 to $700 million. So,
how many jobs would that result in over, say, a 5-year period?
That's a study that yet to be done, but just to staff the floating ops platform, there's 100 people. It'll be the equivalent of a good-sized cruise ship. There'll be nice staterooms and nice dining rooms and entertainment. Of course, interconnectivity with the world for entertainment and staying close to home. But the industry of offshore oil rigs, there's a whole bunch of people that are used to spending 3 or 4 months out there in the middle of nowhere. We'll make it nicer than that. I say we will. Somebody will make it nicer than that.
One of the biggest arguments for international water is legal.
Yeah, I didn't touch on that. Yeah.
If you put it in Botswana, what legal rules, rule of law, et cetera, et cetera. So the real answer for a corporation to build something that would be at risk if you put it in a country that wasn't solid is damaging. We've almost concluded that it's got to be in the middle of the ocean. And then if you go to the middle of the Pacific, it is Pacific. There hasn't been a lightning strike where we're looking for 100 years. There hasn't been any hurricanes because they don't grow on the equator, et cetera, et cetera, et cetera, et cetera.
One of the things Fisher wanted me to touch on, and I think I failed to do so, was I think the first thing I told Peter when I met him, Pete Swan, when I met him a few years ago, was I didn't know what ISEC was. I thought it might have been a funded corporation. Of course, it isn't. But I said, get yourself a bunch of international lawyers on staff, because there's going to be lots of there's the law of the sea, there's the law of space, and all those things have to be dealt with. Rights, 200-mile limits, all that kind of thing come into play. I have experience with that, though. I think, Kevin, I don't know if you ever studied Kevin, have you ever looked at the Alameda Corridor, which I had a big part in developing? The Alameda Corridor is a railway infrastructure through the metropolitan area of Los Angeles, which was crisscrossed with rail lines that were developed by 3 or 4 separate railroads. In order to expand the harbor, the so-called 2020 plan, to achieve the image that Fitzer showed you earlier, both ports got together with the Army Corps of Engineers and developed the so-called 2020 plan. As mitigation for that, because it was going to bring rail back to the harbor and start developing mile-long trains and then have them impact as they move east out of LA, the traffic impact would have been amazing and intolerable. So we literally came up with a concept of a consolidated rail corridor. And ultimately, we created an authority under state legislation that allowed us to, pardon the expression, strong arm the railroads, and they're very tough to strong arm, and say, you will use this corridor. We'll build it for you. It cost $1 billion, which was a lot of money in those days. It's pocket change today, of course, but we will build the corridor. You will use it. And you will not only use it, you will pay us a fee for using it. Now, of course, their reaction was, what? Well, the answer that we replied to that was, you will use it or you won't use the harbors. You won't move any cargo out of LA or Long Beach. So you do need that kind of legal authority to do something like we're talking about to build space elevators.
Well, and one question, you mentioned the whole international water to avoid the sort of difficulties that would come from the majority of the countries that reside along the zone for this equator. The Atlantic is bad because the British Navy can threaten it, and hurricanes. I'm waiting for Adrian to respond because there's a lot. And I'll continue.
The thing is, our aircraft carrier has all your planes on it. They're all American F-35s.
But the problem is there's a country in the Pacific that has demonstrated a willingness to steal whatever it wants, and not the U.S., which is also willing to do that. And so is there not a need for some sort of official or unofficial seal of approval from a major power?
Of course. And of course, the country you may be talking about is doing certain things in the South China Sea. Is that the one you're talking about, Tim?
I wouldn't be slanderous to the great.
No, I loved it. I spent a good month in the South China Sea in my Navy career. It's a lovely place. But no, obviously you get into, since that same country, if we're talking about this, it was also planning to build a space elevator and has the same vulnerabilities, whether it's on land or sea, I think, yes, of course. There will have to be international agreements, and there are agencies, and there may be new international organizations formed to cover space elevators. That's why I say we need probably 10 years of good legal work along with all the engineering we have to do.
Or Adrian's aircraft carrier to sit beside him.
From a logistics perspective too, don't a lot of you guys design, you have the earthport as the anchor, but you have certain conical designs, to say nothing of Natman's active structure, where you're going to actually have multiple positions in a general region kind of going into a cone, which would make securing the space elevator quite a bit more difficult. What distance apart would those be at the surface of the ocean in your designs to make that conical structure?
Well,
the
ahead,
first thing here is that we're just still looking at that as an alternative, and the answer to the question is it'll be set up as necessary, hoping that we recognize what we're just talking about is that there will be international agreement that there will be space elevators. I mean, I don't think we can turn this upside down saying because my legs on my tripod or five-legged tripod are too close or too far apart means there's no elevator or not. That has to be put on the table. We have to have a solution-oriented international agreement, because the inverse of that is unacceptable. We can't say I don't think we can allow, and I don't think the Chinese would allow, even in a non-competitive environment, that we won't do space elevators because of some sort of structural thing. That was certainly I proposed to do work on the Alameda Corridor. There was no question ever that there wasn't going to be an Alameda Corridor, because there was no question that we were going to have a mature Port of Long Beach and Port of Los Angeles. No question. And when the surrounding states realized that 35 to 40% of their employment was going to come from the fact that there was a Port of Los Angeles, even the Environmental Protection Agency, which is an example that Vern didn't mention, they retreated. That's a long story, but it was a non-threatening retreat. Everybody knew we were going to have a Port of Los Angeles. Yeah,
different take on.
And by the way, Tim, just right between the eyes here, that's what I meant when I talked to you several months ago. You need to define authority here. Okay, Vern got authority and did it. That's the image I think we want to protect here. Project. I said protect. Project here. Sorry about that, but that's what's happening.
Kevin, was that you with the question about the difference, the distance apart? Was that your question or that Tim's? I didn't.
I mean, that was just sort of mine of how
Yeah.
far apart. Because I mean,
Yeah, well,
structurally it could be a lot.
no, what we have presented was basically a concept I came up with, that separating the ops platform or the ops center from the actual tether terminus. So I came up with a concept of many concepts you'll see in the literature, and many of them on on the YouTube show the tether rising right from the same place that you have the control center and all that, but that's probably not the best thing to do. So I arbitrarily chose 1 hour away by offshore service boat, and that's 20 kilometers. So if we have two tether terminuses and you put the floating ops platform in the center, you end up with basically a 20-kilometer separation. So you have maybe a 40-kilometer circle, and then you go to space from that, and it creates the spaces of the other regions. That's all going to change when we get in design. Like I say, I'm a civil engineer, not a nautical engineer, but the concept is to maintain at this point in development as much flexibility as we can. And these things probably will have to move. They'll move because of changing tides, weather. Again, we still don't know what the actual stresses will be, so that's where we need that simulation study someday. But it's all stuff that can be done right now with funding, of course.
All right, so as we head into our final event of the day, our expert panel, I'd like to thank you all for joining us for Blue Marble Week. The Foundation for the Future hosts this event each month in order to educate about and advocate for space infrastructure development.